In this video, we'll explore how hydraulic shock absorbers work, more specifically, twin-tube and monotube shock absorbers. This is a vehicle suspension system. To begin, let's see what would happen without shock absorbers. When the suspension travels over an irregular surface, its elastic element stores elastic potential energy. This reduces the direct transfer of impact to the vehicle body. But if that energy is not dissipated, the spring releases it back into the system, causing bouncing like the one you see on screen. The component responsible for dissipating this stored energy is the shock absorber. A shock absorber converts this elastic energy into heat, allowing the suspension to keep the wheels in contact with the ground. But how does it do that? Let's look at the most common type of shock absorber used in passenger vehicles, the twin-tube shock absorber. To convert elastic energy into heat, this system uses special valves that restrict the flow of oil. But first, let's take a look at the basic structure of a shock absorber. The rod is connected to the vehicle body or chassis. The shock absorber body is connected to the suspension. Notice how these components move as the suspension compresses and extends. Inside the shock absorber body is the working cylinder. Since this design uses two cylindrical bodies, it is known as a twin-tube shock absorber. With the addition of this component, two chambers are formed inside the shock absorber body. The working chamber and the reserve chamber. You'll soon see how they work together. The working cylinder operates completely filled with damping oil. The oil does not escape because of this seal in the shock absorber body, which prevents leaks around the rod. Now observe what happens when the rod moves into the shock absorber body. There is no longer enough space for the submerged rod while maintaining the same oil volume. The oil has to go somewhere, but it cannot be compressed or escape freely. This is exactly what the compression valve is for. Located at the bottom of the working cylinder, the compression valve consists of a small body with orifices that allow oil to pass through. These orifices are covered by flexible metal plates called shims, designed to restrict the oil flow. Now let's see what happens when the shock absorber compresses and pressure inside the working chamber increases. The pressurized oil bends the shims of the compression valve and flows into the reserve chamber. When the shock absorber extends, the pressure difference draws the oil back into the working chamber. On the return path, the oil passes through larger orifices with much lower resistance. This is because the primary function of the compression valve is to control the oil flow into the reserve chamber. Observe how oil leaves and re-enters the working chamber during operation. The resistance to oil flow produces the damping effect, converting movement energy into heat. However, most of the damping occurs higher up. Mounted on the rod is the piston valve. This valve works in the same way as the previous one, but it is configured to resist extension more than compression. Above it is the shock absorber piston. Together, these two components perform most of the damping. Let's see how they work. When the shock absorber compresses, the piston compresses the oil inside the working chamber. The oil is then forced through the piston valve and into the opposite side of the chamber, generating damping in the process. When the shock absorber extends, the same process occurs in the opposite direction. The piston compresses one side of the chamber, forcing the oil through the piston valve and into the other side. In summary, damping is achieved using valves that restrict oil flow during both compression and extension. But what if all of this could be done using a single tube and a single valve? That's exactly how a monotube shock absorber works. Everything happens inside a single cylinder, which is where the name comes from. This design generally delivers a more consistent damping response, especially under demanding driving conditions. In this system, most of the hydraulic work is concentrated in the piston assembly. The monotube design uses a single hydraulic assembly to control both compression and extension. We already know that damping occurs when oil passes through a valve, but without a reserved chamber, where does the oil go when the rod enters the shock absorber body? Inside the shock absorber body are two chambers separated by a floating piston, the working chamber, filled with oil, and the gas chamber. As pressure inside the working chamber increases, the floating piston moves and compresses the gas, compensating for the volume occupied by the rod. In summary, the monotube shock absorber performs damping using a single piston valve that restricts oil flow during both compression and extension. The volume difference caused by the rod entering the shock absorber is compensated by a gas chamber, which compresses as pressure rises inside the working chamber. And with that, we conclude the explanation of the hydraulic shock absorber. Don't forget to comment which systems or components you'd like us to explain in future videos. Thank you very much for watching.